Welcome, everyone. This is Michael Gibbs, and I'm the founder and CEO of Go Cloud Careers. And we are here for day 5 of the Azure Solution Architect Expert Training. This is free Azure training, and this is a free AZ305 Azure course. This is the 5th day. Apologize. We had to take a couple of days. I had COVID, so we did the first 4 days while I had COVID. The COVID got too bad, so we're back for the 5th day, which we're super excited for. Today's program, again, is the Azure Solution Architect Expert Training to prepare you for the Azure Solution Architect Expert Exam, otherwise known as Azure Certification, Azure Architecture, AZ305, and this is a Microsoft Azure Solution Architect Training. This will help you with your Azure certification. It's free Azure training, and it's a free Azure course. So we want to make sure you get that Azure Solution Architect Expert certification, but more importantly, we want to make sure that you have the knowledge. So please, I want to tell you this. We are going to be talking about concepts in general. So if you would like to get some hands-on experience, guess what? Fill in the form to get special access to our Azure Lab demos, and we will walk you through how to configure all these things. You can sign up in the link and the description, which is in the chat box as well as below. Couple things that I wanted to let you know all about. A little housekeeping for today. We're going to do about 20 minutes of presentations, about 10 minutes of questions the entire time, because I want to make sure you understand the concepts, because I want you all to get a quality education. Now, next week, I want to let you know, guess what we're going to have? A free BGP workshop and a free subnetting workshop. You need to understand the cloud is nothing more than a network in a data center that's been virtualized, and you must know networking. So to that end, a free BGP workshop and a free subnetting workshop. Please, please, please sign up. The link is in the chat box and the description below. And if that wasn't enough, guess what? In 2 weeks, we're going to run a completely free AWS Certified Solution Architect Associate Bootcamp. Again, completely free, because I want you all getting whatever training you need. I want to let you know about all those housekeeping things. Also, we're going to run straight through, but we will take a 5-minute commercial break sometime between 1 and 1:30. Here's the reason why. My beautiful, beautiful, beautiful little sweet cat, Cindy, was a little mischievous. She stayed out last night, and when she came home, she had a limp in her leg. So I'm going to have to put her in the cat carrier so my wife can take her to the cat doctor, the veterinarian. So we'll have a 5-minute commercial around between 1 and 1:30 for about 5 minutes. And otherwise, we're going to finish the rest of the boot camp today. So it should be lots of fun. So in the chat box, if you can give me an Azure Solution Architect Expert training. But before we do that, my team has posted the banner, so I might as well tell you. We were out for a couple of weeks, and we know that while we were out, we weren't there to help people. So we've extended our 30% off 4th of July sale, so you can get hired as an architect or a cloud engineer or whatever career you want. We've got a program for you for the cloud architect, cloud engineer. Saeed, I am thrilled to see you. Almighty, I am thrilled to see you. Chindu, hello everyone. Cloud hired in Azure. Eugene, cloud hired. I'm so happy to see you. And Brian over there in Philadelphia, cloud hired. Oh, child, cloud architect, I'm happy to see you, as well as I'm happy to see you, Mr. Geek, cloud hired and cloud architect. Yes. So I love this. Give me a hashtag Azure something. Azure Solution Architect Expert Training. Almighty, fantastic. Tracy May, Azure Solution Architect Expert Training. Leonardo Souza, hashtag Azure, I love it. Ben Christopher, Azure Solutions Architect, I'm loving it. Hasnat, cloud hired, fantastic. Sig Wolf, cloud hired, I'm loving this. And Mina, oh, cloud hired, it's good to see you, Mina. So good to see you. So we're going to have some fun today. Now, today what we're going to talk about are the Azure applications and services. Now, remember, for you architects out here, proprietary services don't necessarily work in a multi-cloud environment, but this is an exam, and we're going to talk about them. And when we talk about proprietary services, and some of these are proprietary and some are not, it doesn't mean they're not great services. It doesn't mean they're not excellent. But When you want to go multi-cloud, which 87% of customers do now, and 97% claim desire to be within 12 months, proprietary services go out the window. But you still need to know what they are because they're on your exam. So that's why we're going to cover proprietary services. And we're going to start this. So today we're going to talk about Azure applications and services. The things that we'll talk about will include managed applications. We'll talk about queue storage. We'll talk about the service bus. We'll discuss logic apps. We'll discuss HDInsight. We'll talk about stream analytics. We'll talk about event hubs. We'll talk about Azure Kubernetes service. We'll talk about App Monitor. We'll talk about application insights, activity log, cognitive services, resource manager, bicep, virtual meet extensions, as well as automation. So it's going to be a fun day. Wow. LM in Mozambique. Fantastic. So let's talk about Azure Managed Applications. What is it? It's an application that bundles resources together and deploys them to a resource group that's managed by a publisher. I know that says a lot. So let's talk about what's a resource group. A resource group is going to be a container that holds related resources together for an Azure solution. That research group can include all of the resources for a solution or only the resources that you want to manage as a group. It enables the cloud owner to offer user-friendly cloud solutions for customers to deploy and operate. Azure Managed Applications, what do? They enable you to create user-friendly cloud solutions. So it helps you do it. It enables the account owners to implement the infrastructure and provide ongoing support. It makes applications available to only users in your organization, which makes it easy for you to push it to an internal catalog, which makes the managed application available to all customers. So let's look at this visually, what it looks like for a second. As you can see, you've got a publisher account, which obviously has full control. And we can create a managed resource group, which has got an application resource group, which can determine what kind of access is provided and where. So I hope that makes sense to you. Let's talk about the Azure Managed Applications. Let's talk about a service catalog. Where have we heard this before? With AWS. A service catalog is going to be a catalog of approved solutions for users to use within an organization. So think about this. Here's what this means. You're in a company, and trust me, I've worked in thousands, and I've helped thousands of companies with their systems. What will happen is somebody is going to go deploy something, and somebody else is going to deploy something else, and somebody else is going to deploy something else, and someone else is going to deploy something else. And the next thing you realize, you got all these applications, and they're not even secure, and they're running on your system. Pretty horrible, huh? What did I used to do when I was younger? They called me Sniffer Boy. I took a sniffer or a protocol analyzer, plugged it into the network, and then I could see who was doing what, which was going to get us hacked. And I'd be at somebody's desk. You, that's got to go. You, that's got to go. You, that's got to go. Now, let's think about it. On the cloud, we can pop everything in a service catalog, and you can only use approved stuff. Wow, that solves all the problems. So now you know what it is. That's the service catalog. Create a catalog of approved solutions and only let your people pick the stuff that works. Done. Perfect. So think about it this way. Here, let's say we're talking about my cat, Cindy. Just take it out of tech. Cindy, you can eat your science diet. You can eat your shrimp. You can eat the scallops that I cooked for you for breakfast. Or you can cook the fresh tuna that, yes, I cooked for my cat for breakfast. I know, a little cuckoo for my cat, but she's a sweetheart. So they're approved solutions. Now, if somebody tried to feed a chocolate bar to my cat, I'd say, no. We don't want her to get diabetes. That's bad for her. I don't want her eating sugar. She's a cat. She's on the paleo diet. So kind of keep that in the back of your mind. Approved solutions keeps you from having problems. Now, let's talk about my favorite place on the AWS cloud, the Azure cloud, or the Google cloud. It's called the marketplace. And here's the reason. Since everything I do is multi-cloud, and all these vendors have these proprietary solutions, guess what? I'm never going to use, unless it's for my cat Cindy's website, something like a WAF or event or one of these firewalls. I'm going to get something very industrial grade, like a firewall. So if I'm on the cloud and I need real security, I'm going to get a Palo Alto firewall or a Cisco firewall or a 4-tenant firewall and an IDS system, etc. And I'm going to buy that from the marketplace. What's going to happen is going to be on a virtual machine. What if I need a really high-end load balancer? Something that gives me much more features and functions than I'm going to get from like an Azure load balancer, an AWS Elastic load balancer, or a Google Cloud load balancer. All the same. I go to the marketplace and I can get an F5 one, which has got a much better feature set and functionality. So I can do that. And that's what the marketplace is going to be. Now let's talk about Azure Queue Storage, which generally speaking can be replaced by the open standards Apache Kafka, which you can use on all your clouds. But it's on the exam, so let's talk about Azure Queue Storage. If you know AWS, it's like SQS. Again, another proprietary service. And the Azure Queue Storage is a service that's going to store a large number of messages. And it can store millions of messages up to the capacity limit of the storage account. And it's commonly used, let's say you've got a web server over here, an app server, and a database server. And let's say the messages are coming in so fast that the database server can't write it. That's a problem, right? You don't want to lose messages. So what do? We make a queue. So we have our web servers, we have our app servers, and we stick this queue. We send all the messages to the queue. And then when the database is ready, it lets it in. Hey, wait, when's the last time you got onto a plane? No, if you were in the UK, they'd say, please form a queue. And they'd say the back of the plane, the middle of the plane, the front of the plane, etc. That's how they board the plane. Same thing. Why do they do it? Because otherwise, could you imagine everybody trying to push each other out of the way to get into the airplane? Not that the plane would get there any faster, but trust me, believe me, people would be in a rush to get in. It would cause chaos. So that's what we're doing. The Azure Queue Storage is a highly available, highly scalable, pre-made service, which means you don't need to set up your virtual machines and install your Apache Kafka and set it up, but it's proprietary. This enables organizations to access messages globally via authenticated calls using HTTP or HTTPS. And the maximum size of a message is going to be 64 kilobytes. Because again, this is small stuff on the way to a database. It's not like we're sending videos to a queue. So why are we using queues? It segments and decouples our network. It separates the application server from the database server, for example. It removes system bottlenecks. And it makes applications much more scalable and much less sensitive to individual component failure. Because even if the database were to fail, we can install all those messages in the queue until we're done with them. Now let's think of this. Normally, on the database side, or anything where we're doing the read-write, we've got a memory, a CPU, and a hard drive limitation. So we have two options. Option one, every database that we have gets 256 cores, 6 terabytes of RAM, 8 times 8 NVMe drives in RAID 0, followed by another 8 times 8 terabyte NVMe drive in 0, giving us about 8 million IOPS. That would work in a data center, right? So we could do this. But wait, do we need to buy a server that big? Or can we buy a server that's half of the size, which costs a whole lot less? Drop the message in the queue and wait for the server to be ready. It enables us to right-size our deployments so it costs less. So kind of think about that. Segmentation, decoupling, scalability, normalizing of our data. Now you know what we're talking about, and that's what we're dealing with queue storage. So what does this look like architecturally speaking? You've got a sender who wants to send something. We stick it in the queue until we're ready for it, and then we send it to the receivers, whatever that can be. It could be used for a database or other things, but lots of time we use these things for databases, and that's why I gave you the example. So while we're at it, let's talk about the Azure Queue storage types. We're going to talk about a storage queue, and we're going to talk about a service bus queue. So Azure storage queues, what are they? It's a simple message queue designed to store large numbers of messages, even millions of them. It can be accessed globally via authenticated calls, either via HTTP or HTTPS. Just like before, we can deal with a message size that's up to 64 kilobytes. And again, it's designed to be asynchronous, meaning it's not in real time. You put the message in the queue, and when the system's ready, it drains the queue and it takes it out. So in this case of the Azure storage queue, it's kind of a publisher-subscriber kind of thing. It's optimized for more advanced integration patterns. It's designed to integrate applications, application components across various communication protocols, data contracts, trust domains, or network environment. And here we're going to be using the service bus to decouple our applications and services. So you've got two kinds of it. Here's an example of using this Azure storage queue. Load balancing work across multiple competing workers, systems doing things, message queuing, and provisioning of Azure resources. Now let's talk about the Azure Service Bus queue. Now what's that? Again, it's a messaging service optimized to connect applications, devices, and services to each other. Again, highly available just like the other queue. Same reasons to decouple our applications from one to the other, to distribute messages to multiple independent backend systems. So kind of like the fan and out. Packet comes in, our message comes in, goes to the queue, and it can be sent to multiple systems at the same time. Now, this will protect applications from spikes in traffic, big peaks and valleys. It'll smooth it out. It'll protect, we can use it to connect our on-prem systems, the cloud systems, and it'll scale out as needed. So these queuing systems really do a lot to improve our application performance and availability. Now, when we're dealing with the Azure Service Bus queue, it provides first in and first out. What does that actually mean? It means message 1 goes before message 2, which goes before message 3. And if any of you guys or girls have an MBA or done some accounting in your life, and you know what I mean by first in, first out accounting, same thing here. FIFO, or first in, first out, means message 1 goes before message 2. Now, FIFO is not always fastest. It might be fastest to send stuff out as fast as you can. But first in, first out guarantees message delivery. And this is perfect for processing messages as for like parallel long-running streams. And this is optimized, at least for messages exceeding 64K, but without approaching 256K or the 1 meg limit. And that's going to be based upon the tier that people are on. Azure Service Bus queue, what does it do? And it's a fully managed enterprise message broker used to connect applications, devices, services. Message broker, to some degree, you can start thinking of other message brokers, like IBM message brokers, AWS, SNS. They're kind of all message brokers, kind of applications to kind of put into context for you. And we do this to decouple applications and services from one another, just like before. Distributes messages to multiple systems, just like we're describing. The whole reason we're going to use Azure Service Bus queue, again, is to decouple applications. So all these queues are designed to decouple applications, but the Azure Service Bus queue is first in, first out. So let's give a look, architecturally speaking, what does this look like? Oh, wow, I am really sorry. My really great graphics artist used I think he called it teal, and I would get a green screen behind me, and the teal turns into all kinds of funny stuff. So it looks a little goofy here, but you can see we have a sender. The sender pops the message into the message queue, and it gets fanned out and sent to the receivers. Let's talk about Azure Logic Apps. What are they? The Azure Logic Apps are a service that permits a user to automate the execution of a business process or workflow through visual design. Logic Apps run in a company's public cloud and helps the users introduce scalable cloud-based integrations and workflows to business processes. Logic Apps provide the user with a visual designer, like a design, to model their business processes and workflows. For any of you guys and girls that are used to it, those of us that do process engineering or management consulting where we make our workflows, well, kind of the same similar concept, but more on the techie side. Here's a perfect example. We've got something, which then does a trigger to something else, which then does something else, which then does something else, etc. So we're able to set up a workflow with the Azure Logic App. Now let's talk about Azure HDInsight. What's that? Well, this is a cloud-based service from Microsoft for big data analytics. It's going to help organizations process very large amounts of streaming data. It's an easy, fast, and cost-effective way to process large amounts of data in a customized, and you can use it with other open source frameworks such as Apache Spark, Apache Hive, Apache Kafka, etc., etc. What does it do? Well, Microsoft promotes HDInsight for applications in the data warehousing space, as well as extraction, translation, and loading situations, as well as machine learning and the Internet of Things. It's the Azure Big Data Platform. Let's just call it spade a spade. HDInsights enable integration with business intelligence tools such as Power BI, Excel, Tableau, etc., those kind of things, visualization and BI tools, SQL Server, etc., etc., etc. And let's do Stream Analytics, and then we'll take a break and answer some questions. Azure Stream Analytics, what's that? It's a real-time analytics and complex event processing engine that's designed to analyze and process lots of streaming data. Like every cloud provider has it. Kinesis has got these kind of things. AWS has it in the form of Kinesis. It's a similar thing. You could also use like an Apache Kafka to do these kind of things too, which you could deploy across 3 clouds at the same time and not have any proprietary anything. But now you know what streams analytics are. It helps with patterns and relationships that can be identified in information extracted via various sources such as devices or sensors or clickstream data from the people on websites, social media feeds, applications. And patterns are used to trigger actions and initiate workflows such as creating an alert, feeding an information reporting tool, storing data for later. Usage example, let's talk about it. So we got all these IoT devices giving us weather sensors. Great place to put it. Company's got 1 million website hits a day. How long does somebody stay on what page? What do they click? What's the workflow? Capture that data for better business intelligence. Make better decisions. You got a fleet of vehicles all over the world, or airplanes. Where are they? We can analyze what's going on. We can monitor remote systems with this stuff. We can get analytics and point of time sale data like inventory control, anomaly detection. How cool is that? If you've got 1 million or 5,000 stores across the world, to be able to know what to buy and when to buy it, so you never run out of stuff. But you don't keep a ton of inventory, which is going to spoil and cost you money. So these are the kind of things that we're talking about. Any of these analytics tools are good. There's lots of them that are out there, but they're fantastic for business intelligence. So let's talk about tumbling. We'll discuss Azure Stream Analytics. We'll talk about temporal windows, at least the way they describe it. They're going to give us a couple of terms that we need to understand. Tumbling, for segmentation of data streams into distinct time segments to perform a function against them. We'll talk about hopping, which is a hop forward in time by a fixed period. We'll talk about sliding, which outputs events only for points in time when the window content actually changes. We'll talk about the session, which is groups events together at similar times, filtering out periods of time where there's 0 data. And we can discuss a snapshot, which groups events together with a series. So realistically, what are we talking about it? We're talking about data ingestion, logs, this stuff. You can do anything with this. You can take your IDS, IPS, your firewall logs and analyze those things and see what's going on with your systems. Your business apps, your IoT devices, your clickstream data. Then we're going to pop it somewhere. We're going to analyze the data. And after the data analysis, we can make better business decisions. So, there's a lot to be said for what goes on in big data and making better decisions through the data that we have. Okay, we will temporarily take 10 minutes to answer your questions before we move forward, because I want to make sure you all have a good time, good experience, and good education. So ask some questions for about 5 to 10 minutes, and then we'll get back to the content. Angela, what are some use cases for messages with stored queues first and first? Well, generally speaking, we're trying to push stuff as fast through a queue as we can. But let's say you have an application, Angela, and I am no application architect. I'm an enterprise architect, a cloud architect, a network architect, but I am not a software engineer. But I do know from my years of consulting, Angela, that there are some applications that are intolerant of messages that need to come in. Let's say a banking transaction. Trade 1 needs to be stored before trade 2, which needs to be stored between trade 3. And in that case, we might use the first in, first out queue with ordered messages. There may also be an application that must have packets in order or data in order. And then again, that's where we're going to use that. But generally speaking, Angelo, when we're dealing with most queuing systems, our goal is to get them in and get them out as fast as possible. So let's think about normally. Let's say message 1 is 64K. Message 2 and 3 are each 1K. Message 4 is 5K. Message 6 is 64K. We might actually be able to get message 2, 3, and 4, which is 3K of data, faster than the first message, which is 1K. So in those situations, we would not use first in and first out. We would use the fastest we could get it through. Now, not all applications can tolerate out of order messages. So that's the reason, Angela. And it's an excellent, excellent, excellent question you asked her. I love it. What else? Okay, well, if there's not a lot of questions, fun. I get to keep talking and teaching. Excellent, excellent, excellent. But before we get back to the content, you can get, and actually 2 things. One is make sure that if you just got here and you want to do some labs and hands-on demos, sign up for the Azure lab demos, and you'll get to see them on our content management framework, watch the videos, configure things, and get some hands-on time as well. But before we begin, give me a hashtag Azure Solution Architect Expert, because that's what we're doing here. Give me a hashtag Azure Solution Architect Expert. If you haven't hit the like button, please hit the like button. We put a tremendous amount of time, effort, and money into these things. Literally speaking, cost us about as much as a new car to produce these things because we want to help people. And we're going to consistently do it as often as we can for you. So give us a like, give us a share, give us a comment, tell a friend to watch some of our free training because we want to help as many people as possible with everything we do. I'm seeing it, Azure Solution Architect Expert. I'm Brian. Has not Azure Solution Architect Expert. It's making me happy. Leo Paredes over there, Sao Paulo, Azure Solution Architect. Robert Welch in Dallas, Azure Solution Architect Expert. And Chal over there in Dallas, Azure Solution Architect Expert. Starting to remember where people live. Angelo, thank you, Mike and team. As always, great community resource with this wonderful training. Thank you so much, Angelo. So happy to do so. Chindu, Azure Solution Architect Expert. And Ben Christopher, Azure Solution Architect, and Charles Finney, Azure Solution Architect, and Almighty, fantastic Azure Solution Architect Expert Training. Tracy May over there, Azure Solution Architect, and Hannah Bagad over there. I think you're in England from our past conversations, Azure Solutions Architect. So let's discuss Azure Event Hubs. Now, what is an Azure Event Hub? It's a scalable processing service that ingests and processes large amounts of events and data in a low latency, high reliability environment. It provides data processing, which continues during emergencies and disaster recovery. We use it to stream millions of events per second from any source. And we're doing it to build a data pipeline so we can immediately respond to business challenges. It allows existing Apache Kafka clients and applications to talk to Event Hub without code changes, or just set up Apache Kafka and keep using it without using a proprietary service. But that's either here or there. It's a great service, just proprietary. It works with ACI Logic Connector apps, Azure Queues, Azure Functions to build a strong infrastructure that scales out. Let's talk a little bit about Azure Container Instances. It's a service that enables you to deploy containers in the Azure cloud without provisioning any underlying infrastructure. Now, you could put your containers in a virtual machine. And if something happened with your cloud provider, you could take that virtual machine to another cloud provider and all your containers go with you. That's what I would do. Or you can use this Azure Container Instances, and it's automatically done for you. So it eliminates the need for a developer to provision virtual machines, implement a container, and it runs your organizations. But guess what? You have no control in these managed solutions, how well they perform. You are at the mercy of the cloud provider and their capacity. It's not like your own virtual machine where you say, this is the disk performance I need, and this is the memory I need, and this many CPU cores I need. It's a managed service. A managed service means you get what you get. You can't do much about it. But it eliminates the need to set up your own orchestration platform, such as Kubernetes, et cetera, et cetera. So it is a pre-made solution. There's nothing wrong with pre-made solutions, but whenever you design it yourself, you have a lot more control. You can promote greater security and performance. But if you want your people not to focus on the infrastructure, not that you would, but if you're a small business and you didn't want to worry about the infrastructure, doing it this way makes it easier for you. So lose control, lose performance, lose security, but less work to do. So it's a trade-off. Sometimes the trades make sense. What's it look? You take your system, you push an image to the registry container, and then you've got your container instances, and it runs in a serverless sort of way. Kind of like Amazon's, Elastic Container Service with Fargate, same concept. All the cloud providers have it. Now let's talk about the next one, Azure Kubernetes Service. Now we're already walking up the ladder of interoperability. And this is really a fully managed Kubernetes container management service, which will deploy your containerized and orchestrated applications with Kubernetes. It simplifies the monitoring and cluster management through auto upgrades. It provides integrated security and governance, and it achieves higher availability by using multiple availability zones. There you go. What you can see is you've got your apps, you push them in, it's fully managed by this, and we've got, Kubernetes, pod auto-scaling, etc. Again, you could manage your own cluster, set up a couple of virtual machines across every cloud, manage your own Kubernetes cluster, and not get involved in any of these things, which is what you would do in multi-cloud. Or you could use the pre-made service, and then you don't think about having to set up your clusters. It's up to you. It's up to your clients and what they need. Let's talk about Azure Monitor. What is it? Azure Monitor is a reporting and analytics tool that provides information to help you make better decisions. Azure Monitor maximizes the availability and performance in your applications and services. It provides solutions for collecting, analyzing, and acting on telemetry data from your cloud and on-premise systems. Helps you diagnose and detect issues across your applications and dependencies with Azure Application Insights, and it supports operations at scale. Visually speaking, what's it look like? You can see you've got your applications, your operating systems, your resources, your subscriptions, your tenants, and you're getting all this information. And then you can take this information and ingest this information and look at it, visualize your data, analyze your data, and make better business decisions. That's why we do this. We're trying to make better business decisions. The whole point of all of this is collect data so we can make better business decisions. Like I said, and I always tell my architects, the tech doesn't drive anything. The business requirements drive the tech. Kind of like if a carpenter had a house to build, they would know what they have to work with. If I've got to drill through steel, I need a special tool. If I have to drill through cement, I need a special tool. The tech is just a tool, but we're using the tech because it can help us make better business decisions. Those better business decisions can make the business more profitable. That's why organizations invest in technology. Nobody buys tech because it's cool. I promise you that, except for people like me. I got a house that sounds like a jet engine from all the servers in here, but I like tech. It's fun for me. But if it wasn't, I would not be behind it. So just keep that in the back of your mind. Azure Application Insights. What is it? It is a cloud-hosted software as a service tool that allows an IT staff to collect and search data from multiple machines for analysis. It automatically detects performance anomalies and diagnostics with analytical tools. What does it do? Well, it provides additional functionality and application performance management for monitoring live web apps. It integrates with your DevOps or your CI/CD pipelines. And this really works for apps that are hosted on premises, hybrid, or public clouds. Collecting your data and giving you information. Let's talk about Azure Activity Log. Well, logging's everything. When stuff breaks, how do you know? You look at your logs. What happened? We talked about logs and streaming data, right? Every system you have spews out a log. Log. You got 10,000 routers. 10,000 routers are dumping syslog files. Got 100,000 servers. Those 100,000 servers are dumping out log files. I mean, you got a firewall. Every time it denies a packet, it's going to give you a log file. The point is you're going to get logs, and more logs. Now, trying to figure out what goes in the logs is not so easy. Typically speaking, people make custom tools. They write scripts in Linux, for example. But tools are better. So the Azure Activity Log is a tool used for consolidated monitoring when resources are started. It gives you insight into subscription level activity, when a resource is monitored, when a VM is started. It lets you view the activity sign in the Azure portal or retrieve entities via the PowerShell or the command line interface. What does the Azure Activity Log do? Well, it enables you to send your activity logs to Azure Monitor Logs, which gives you increased complex querying, alerting, and retention for upwards of 2 years. It enables you to send your data to the Azure Event Hub to forward activity outside of Azure, or it enables you to send all this information to Azure Storage for cheap long-term archival purposes. And who knows, in the future, you got all this stuff. Maybe you run some machine learning on it because it's cheaply stored. So let's talk about Azure Cognitive Services. And what's that? It's going to be a cloud-based artificial intelligence service that's going to help you build cognitive intelligence to your applications to create intelligent applications, smarter applications. It's a set of machine learning algorithms that are pre-made for you and designed to solve problems in the field of AI or artificial intelligence. Now, mind you, you don't have to use any of these things. Your data scientists can write their own codes and do it the way they want, but this is pre-made stuff. What does pre-made mean? Cookie cutter. What does cookie cutter mean? Optimized for the average user. So understand, any cookie cutter everything can never be optimal because it's designed for the average ordinary user. So why do we use these things? Because they're easier. So for a small business that does not have good data scientists, they get to use these cool tools. They're easier to use and they require less sophistication. And that's why we're going to talk about these proprietary services. Otherwise, we can hire the data scientists that know what to do, how to do it, and when to do it, that can build us exactly what we need for our business. So let's discuss Azure Cognitive Services. What's that do? It assists in building cognitive intelligence into application through cloud services like with REST APIs, client library, software development kits, and user interfaces. Cognitive services are going to be categorized in 4 pillars: vision, speech, language, and decision-making and decision. Let's talk a little bit about the things we can do with Azure Cognitive Services Vision APIs. It gives us computer vision, which provides you access to advanced cognitive algorithm for processing of images. Maybe you want to search an image for something you don't like. Let's talk about custom vision. It enables you to build, deploy, and improve your own image classifiers. Face provides access to advanced face algorithms, enabling face attribute detection and recognition. Pretty cool stuff. In Azure Cognitive Services, let's talk about speech APIs. We've got a speech service, which enables things like speech to text, text to speech, speech translation. Pretty cool. I see there's a guy named Alex. I happen to look at his last name and I know he's Greek. I could speak to him in English and have it translated to Greek, or I could speak to him in Greek and have it translated to English. Whatever the case is, I think it's cool. Love these text-to-speech, natural language processing kind of things. Azure Cognitive Services. Now let's talk about language APIs. We've got the Azure Cognitive Service for Language, and this provides several natural language processing features to understand and analyze text. Got a translator. Oh, I love that. Translate languages in your real time. I love that. Just love that. Language Understanding Lewis. This is a cloud-based conversational AI service that applies machine learning to conversational or natural language text towards predicting the overall meaning to try and pull out the relevant information. And we even have something cool called Q&A Maker, which is for building a question and answer service for your semi-structured content. Let's talk a little more about Azure Cognitive Service Decision APIs. We've got an anomaly detector, which is going to be used for monitoring and detecting anomalies in your time series data. We have a content moderator, which monitors for potential offensive, undesirable, or risky content. And we have something called a personalizer, which monitors for offensive, undesirable, or risky content. And, big companies that have thousands of people producing video content, speech content, graphics content, need a way to make sure that somebody doesn't post something that's pretty offensive. Here we go for 5 more minutes before the next series of questions. Azure Resource Monitor. What is it? It's the Azure Deployment and Management Service. It is a management framework that allows administrators to deploy, monitor, and manage Azure resources. This management layer enables a user to create, update, and delete resources. And it's going to include the following management features: access control, locks, and tags to secure an organization's options and resources. Let's graphically look at it. Here in the Azure Resource Monitor, let's say we've got the Azure portal, the PowerShell, the CLI, we've got our software development kits, and now we've got our resource manager, which we can then use to manage things. Actually, we'll go a few more and then we'll open it for some questions. Azure Bicep. What is it? It is an infrastructure as code tool. It is a proprietary tool. It's similar to AWS CloudFormation, and it also serves the same function as Terraform, except that Terraform works on all your clouds, where Azure Bicep only works on one cloud. You know my perspective of AWS CloudFormation? Trash. You know my perspective of Azure Bicep? Trash. If you've got a DevOps team, they should use Terraform because it works across all clouds. It is neutral, interoperable, and that way you deploy your thing on one cloud, you don't like it, poof, you're on another cloud, easy peasy. But AWS CloudFormation, Azure Bicep, now it's all in this domain-specific language. So the world is all about interoperability and talking to people all over the world. So Azure Bicep is an infrastructure as code service. It defines the infrastructure you desire to deploy, and then it deploys the process. It gives you a concise syntax, repeatable way to type it again and again for reusing your code, and its support for all resources and API types. Let's talk about Azure Voicemail Extensions and virtual machine extensions. What are they? They're going to be small applications that provide post-deployment configuration and automation, like a Bootstrap. Hey, wait, come up, patch your system. Done. Then install an antivirus. Poof. Install these 3 packages. Sorry about the coughing. I don't have COVID anymore, but I got to tell you, this cough has been lingering. I'm still a little tired. Hopefully it goes away soon. So realistically speaking, we can run it via the Azure CLI, PowerShell, Azure Resource Manager, templates, etc. Now let's talk about Azure Automation, and that's going to be a service that allows users to automate their management tasks and orchestrate actions across systems. It's going to enable people to do cost-effective things with low upfront costs. Now, Chris, let's open it for questions for a few minutes. We covered a lot of these proprietary services. Good services, but proprietary services. So we've got some questions. Ask some now. And Chris, if there are any questions, I see one from Almighty. Let me know and we'll answer them. Almighty, can I explain what is Terraform? Absolutely. So Terraform is an infrastructure as code platform, and here's typically what it uses. We have a DevOps engineer that will write code that will literally deploy our entire things. It is so great that when people say, hey, Mike, where are all the entry-level cloud jobs? And I say, there are none. And they say, what do you mean? Where's the guy or girl that goes and configures this stuff? I say, why would you need anybody to configure this stuff? One DevOps engineer can literally write out a full deployment and could literally deploy a bank in 45 minutes, replacing 10s and 20 cloud admins in a single instance. So this is an automation tool that enables you to write your code, typically Golang or something like that, where your engineers, not your architects like you, Al, architects like us will never touch Terraform because we don't configure anything, we design. But our cloud engineers may use Terraform, and we train our cloud engineers with Terraform, and DevOps engineers definitely will be using Terraform. And here's what they're going to do. They're going to say, okay, I need 1,000 virtual machines. I need this many subnets. I need this many stores. I need this Kubernetes cluster. I need to deploy these 3 databases. I need this many load balancers, etc. They'll write their code, and poof, they'll kick off the script, and it's all deployed. That's exactly what you would use. Chris, bring in the next question. Lawrence, I mentioned this in our Go Cloud Communications, though overall, how would you use Red Hat Linux or Red Hat as an architect? You wouldn't at all. Architects don't touch the technology. We design, present, and sell. So how would we use Linux or Unix? We might say we need 1,000 virtual machines. We recommend Red Hat Linux. We'll spec out the CPU resources. We will spec out the DRAM resources. We will spec out the type of storage resources we need. And we realize we're on the cloud and block storage is pathetically slow, regardless of what the cloud providers say. So we'll determine what kind of RAID levels we need. And we will determine what our load balancers need to look like. We will design our IP addressing scheme. We will define our database. Do we use a NoSQL database versus a relational database? Do we use both? How do we scale the databases? But we don't touch the tech ever, Lawrence. Been an architect for 25 years. We don't touch the tech. Got lots of students that graduate. They're getting hired all the time. I have a student in England that called me and he said, Mike, he said, you taught me so much tech. He said, all I've done is I took the job, brand new car showed up on my car part. He said, I've gone to meetings, I bought dinners and drinks and delivered presentations. It's been a year now and I've never touched the tech. Am I going to? And I said, no, never, ever. Architects don't touch the tech. So how do you use Linux? We don't. Now you will use Word, and you'll be writing in Word all the time. You'll be using PowerPoint and building, presentations. You may be using tools such as Draw.io or Visio or Lucidchart to draw a picture. Now, Lawrence, when you get better and you're a more senior architect like me, you will literally draw things on a napkin. You will take a picture of the napkin and you will send it to a graphic artist to have it do it. You'll respond to requests for information, requests for proposal, requests for queries. You will give presentations in front of audiences with 5,000 and 10,000 people. You'll present to the executive team. You will be negotiating billion-dollar plus deals. But no, you will not be touching the technology as an architect ever. You design, present, and sell. Now, that's if you're working for a consulting company or a cloud provider. Now, what if you're working for a bank, for example? You're still going to design, present, and sell. Wait, how do you sell to the company? Well, you're an architect that works for a bank. Now, here's what you do. You're going to speak to the executives of the bank. What are your business goals, your business pain points, your business challenges? Then you're going to talk to all the department heads. What's going on with your system? What are the challenges? Then you're going to bring in some engineers and you're going to baseline the systems and collect some information, which are going to manage that team. And then when you're done that, what you're going to do, you're going to write a document which you'll present to management, deliver your presentations to management, and convince the management they need to do things. So that's exactly what you need to do. We architects don't touch the technology. And that's why when you see certification providers saying, here, I'm going to help you get hired by put something on Git. I've never touched Git in my life. That's a DevOps engineer tool. That's a certification provider that doesn't even know what an architect is because they've never been one themselves. They're just getting certified and teaching courses. So no, we will never use Linux in our life. You will never touch the console. You will never touch the command line. You will never touch anything other than Microsoft Word, Microsoft PowerPoint, and you're going to design, present, and sell. You know what, Lawrence? One year I spent $100,000 on lunches with a company credit card because that's what we do as architects. We entertain clients. We take them golfing. We're part of the sales team. We design, present, and sell. So if you're doing anything that doesn't involve design, present, and sell, like learning code, it's not an architect's job. It's not going to help you. And Lawrence, it's even worse. Once you start putting those skills on a resume that's somebody else's job, you look less like the architect in the first place. So study for your career. And Lawrence M., tomorrow I'm going to run a How to Get Your First Cloud Architect Job webinar. And I will spend an hour telling you everything you need to learn to be an architect. And then you can come off cut on mute and ask me questions because I want you all getting hired. My students are not. I'm glad you didn't get too far. You prefer working in cloud, lucid chart, and designing as presenting. Yeah, good. That's what we do. We design, present, and sell. You're using a FreeM VirtualBox to practice while going through the recommended readings through recommended just dropping that for now. Lawrence, I want you to learn how to design, present, and sell. That's it. Design, present, and sell. You'll note when we're teaching this course, we're talking about the stuff and how it works. And I'm saying, hey, wait, you can download or sign up for the free labs. The reason is the cloud admins need to know how to do this. The cloud engineers need to know how to do this. Cloud architects don't touch the tech. Now, we need to know how the tech works because you can't design what you don't understand. That is the most critical thing. For us, it's all about the how. I mean, the why. For the engineers, it's all about the how. Lawrence, I'm going to summarize it on this. If I wanted a hotel built, I would hire an architect. I would say, I want 10,000 rooms. I want a waterfall, a garden, an infinity pool. I need a presidential suite. I need 10 honeymoon suites, et cetera, et cetera. I need 6 restaurants. And the architect would build blueprints. That's what the cloud architect does. Now, that architect would not build the hotel. The architect would deliver their designs to me, and if I was the hotel builder, and I would then hire a construction crew, meaning the architect doesn't use a screwdriver, the architect doesn't hammer nails, the architect doesn't use a saw or a drill. They don't touch the tech. They don't build anything. They are a system designer. All architects are systems designers. We don't touch the tech. Also, think about it this way. You need to know how to design the tech. So if I'm going to connect to 3 clouds, you need to know what routes are you sharing? How are you aggregating routes? Or you're summarizing your routes? How to design your BGP, load sharing or blocking, etc. We don't lay out any steps for engineers. We have no idea how to do their job. None. And what this would be like is, for example, you got a pilot on a plane. The pilot is in charge with getting the plane to its destination. The flight attendants are in the back making sure people are safe, keeping them in their seats. Deploying oxygen should anything need. Patients got chest pain. They come over, they administer oxygen, and they say, is there a doctor on the plane? Now, the pilot will say, hey, wait, we're experiencing turbulence. Please sit in your seats. But the pilot does not tell that flight attendant how to do their job. We don't tell anybody how to do their jobs. Imagine me as a nurse practitioner trying to tell a physical therapist how to do his job. I'm not a physical therapist. I didn't go to school for what they did. I don't know how to do it. So what do I write? I write a prescription that says, evaluate and treat. The physical therapist comes up with the physical therapy plan. I can't tell them how to do their jobs. And never should we ever tell somebody how to do our jobs. Because we're leaders, Al, as an architect. And the second you tell somebody else how to micromanage them and do their job, they're not helping you out ever again. So, good question. Lawrence, Mike, you're absolutely not charging enough for the value you provide. Thank you for helping in your career pivot journey. We are thrilled to do so. We're running a course which is realistically worth about $50,000 with the content we put in it. We charge basically a single day's pay for the average graduate. And the reason we do this is I'm blessed. I had an incredible architecture career and I don't need to work. We charge what it takes for the most part for me to maintain an all-star staff. Having a chief operating officer with an MBA like Chris, who's rock solid and has lots of experience, having Alonzo on my team, another C-level executive, having, Chow and Leo on my team and Eddie on my team, making sure my students are successful. We charge what it costs for us to help our students get to their goals. And then we can answer Ashwini's question, which is a good question, and we'll get back to the content. Cloud engineers must code. Cloud architects don't code. Cloud engineers must code. Cloud engineers must know Linux. Cloud engineers must know Terraform. Cloud engineers must know how to write a bash script too. So cloud architect, design, present, and sell. Not super technical, but our technical for us is how to design it. So we need to know how it works. Cloud engineers, code, computer. Cloud engineer is the person who's behind the computer all day. The cloud architect's the person that shows up in a suit maybe and takes somebody to dinner. They take them to Morton's or Smith & Wollensky and, you buy $200 bottles of wine on the company account and $25 shots of scotch. Entertain the client and get them talking. Totally different jobs. But cloud engineers, programming. Cloud architects, no code, no configure, no hands-on anything. Okay, so to remind everybody, please sign up for the free subnetting workshop and the free BGP workshop. Link is in the chat box in the description. Please sign up for the completely free AWS Certified Solution Architect Associate question. Certification bootcamp that we're going to run. It's completely free. We want to help you guys get hired. Link is in the description below. And like Al said, you're good at spending money to make a deal. Yeah, in this job, you're going to be spending lots of company money to make lots of deals. So let's get everybody cloud hired, everybody. And at some point, I hope my wife is home so she can take my kitty to the veterinarian. I'm so upset. She came home. She was mischievous, stayed out all night, and she's got a limp. So at some point, we're going to roll a commercial, and I'm going to have to put my cat in the cat carrier, and then we will finish. So if y'all give me a hashtag Azure Solution Architect Expert Training in the chat box, we'll get back to the fun. So we're going to talk about my least favorite topic, which is cost management. And why is it my least favorite topic? When people come to me, they say, Mike, I need digital transformation. And my designs are never, ever cheap. They're super expensive, and they all make the company money. But and that's why I've always been more of a finance person, which determines how to help people make money, as opposed to an accounting person, which helps people save pennies. But it's good to know how to do both. So when we're talking about cost management, what we're talking about is optimizing costs. Now let's talk about the data center. Me, I love the data center. Cloud's nothing more than a data center and a network that's been virtualized with some software on it. And I built lots of clouds and more data centers than I can count in my career. So in the traditional environment, we have some extremely high capital costs because we've got thousands of servers usually. Got these Cisco and Juniper high-speed routers. We've got these Cisco switches most of the time, but it could be other switches. We've got our Palo Alto, our Fortinet, our Checkpoint, our Cisco firewalls, and our IDS systems. We've got our F5 load balancers. We've got these big metal racks. We've got power distribution units, which give power per rack. We've got UPS systems, which are big battery systems that back up our generators. We have multiple generators because data centers don't have power failures, except for one, and I don't believe it, but data centers don't have power failures because we have two power companies, and we've got these big, $20,000 transformers each, and we've got a lot of them. We're going to have generators, so there's a lot of cost. Now, what does it take to cool a data center? Oh my God, you can't even imagine the electricity that we actually have to deal with. And there's the real estate involved. We're buying big, giant buildings. Where are people's data centers? Well, a lot of times they're where their business is located. You got a business in New York, and now you need 20,000 feet of data center space in New York City. Ugh, expensive. That's why they moved into Jersey City, which guess what? This is a fortune. But, these are the kind of things. So when it comes to the data center, we're typically talking about capital expenses, meaning things that we purchase. Now, we still have operational expenses when we deal with the data center, such as the team of people that we have. On the cloud, we can use a smaller team. We have massive electric bills, and we have massive, massive wide area network connections. But the majority of costs are managing the equipment. The other costs are basically for operating the equipment. Now, when we go to the cloud, things change, and it doesn't necessarily make it cheaper. It changes the cost structure. In the data center, we're predominantly capital expense. Capital expense is buying a house. You buy it once and you own it forever. What determines your cost of the house? The amount of the house and your financing, assuming you don't just pay cash for it, a single plunk down your cash. So what is the organization's capital expense? Typically speaking, their weighted average cost of capital. What does that mean in layman's terms? If you got a house with 4% mortgage rate, that's your weighted average cost of capital, 4%. So we're going to have to do a business case per customer and determine, is it cheaper for them to buy and finance their own equipment or go to the cloud and rent it? Isn't this the same business case that you face? Should I buy my house or rent my house for long-term wealth? And for that, you got to determine your closing costs on the house, your mortgage rates on the house, how long you're going to stay in the house, et cetera, et cetera. It's the same business case here. The cloud providers obfuscate and make it sound cool and funny, but it's the same business case we do for everybody. So when you go to cloud computing, there's not a lot of equipment to purchase. You buy your wide area network for the most part, and the rest of it is on the cloud, which means you're renting as opposed to buying. So on the cloud, well, there's very limited capital or one-time expenses. The operational costs on the cloud are sky high. Sky high. Let's go back to the landlord. If a landlord finances a house and it costs him $2,000 to finance it, he's going to charge $2,500 or $3,000 to rent it to you. Cloud providers are doing everything as a landlord. They are buying all the gear and they are renting it to you. That's all cloud is, a rented data center. So with cloud, they like to call it pay as you go. I like to call it pay as you configure, but they like to call it pay as you go. So capital expenses are minimal because you're not buying a lot, but operational costs are sky high. Is that good for the business? Like if you take an AWS certification, you can tell somebody that's been certified that knows nothing about architecture because they say, it's great. We shift from capital operational expenses into the win. And if you say that to a business, I promise you, you'll be fired in your first 5 minutes. Your replacement will say, thank you for the $200,000 job and take it and run with it. So I want you to understand there is no time where we can say operational expenses are better than capital expenses without running a business case. That would be like somebody telling you, always cheaper to rent your house than to buy your house. Not true. So we will have to build the business case, and can't do that in certification, but my students in the Cloud Architect Career Development Program obviously know how to do that. Or if you have an MBA, you got to learn this because it's critical to the architect job. Now, when you understand when you move to the cloud, we got to look at the cost. In most cases, but not all, it's a little bit cheaper to go to the cloud than manage a data center. A little bit cheaper. But, In most cases, it's cheaper. But what is the cloud? Agile. Now, even if it costs the same thing and the cloud doesn't perform as well as the data center, and it doesn't, the ability to be able to add a server in 6 seconds versus having to call Dell and wait 6 weeks for the server to get delivered to you is everything. That's why we're on the cloud. That agility, speed is amazing. That's why we're on the cloud. So let's talk about managing costs. The first thing you need to do is provision only what you need. Makes sense, right? Don't buy 2 houses or rent 2 houses when you only need 1. Step 2, properly size your resources. What does this mean? It means know what you need. It's going to cost you more for a server with 128 cores and 6 terabytes of RAM than it's going to cost you for a server with 4 cores and 16 gigs of RAM. So provision what you need. Now, if you know what your resources are, you're in good shape. What if you don't know? What if you don't know? Well, then you're in a totally different position. Totally different position. And here's where we're going to talk about things. So what you really want to do is, from a cost perspective on the cloud, is size your system based upon the average use. What do you do in the data center? You size based upon peak use. So this is one of the cost-saving features of the cloud. In the cloud, I have a retail company, and I'm building up for the day called Black Friday in the US. It's the busiest shopping day in the country. So what do I do in the US? I build my systems for the Black Friday and Christmas holiday season, and the rest of the year they're running at 3%, and at Christmas they're up at 95%. They might even peak and I lose business. In the cloud, I want to build it for what I need most of the time, and I can scale out or add capacity as needed. That's where the cost savings is. How else do you cheapen your systems up? You decouple your systems. So today when we talked about the managed service queue and managed buses or the queuing systems, and I may have the name wrong because, to me, I would use Apache Kafka and not have to worry about proprietary systems. So there's that. But by doing it, we can use smaller servers through message queues. So we want to decouple our architectures whenever possible. Step 3, use the right platform for your business. What does that mean? If you don't know what your demand is, you want to use on-demand systems. If you know that you need a server with 64 cores and a half a terabyte of RAM, and you're going to need that identical server for 3 years, reserve it and get a discount. Now, all of these systems have the equivalent of a spot instance or a preemptible instance. And what is that? That's excess capacity in the Azure network that you bid on like an auction. And what's the problem with that? Somebody bids higher than you, your systems get shut down instantly. So that's not good either. So here's the thing. Cost optimization is determined when you mix all 3. Reserve what you can, use on demand for added capacity, and use the spot equivalent when you need it. Step 4, something I struggle with, leverage managed services and serverless. When you use a managed service or a serverless service, it's typically cheaper. Now, having said that, when you manage a service or serverless and the cloud provider raises your rates, you're in real trouble because you got to spend a fortune configuring applications to go. So I'm not a fan of serverless in most cases because I like agility and I like 3 clouds. And I don't use proprietary services and I don't use managed services whenever possible because I want my customers to have agility. But in some cases, they're cheaper. Here's what happens with managed services. You lose availability, performance, and security at the top end because you can do more on your own, but what you get is cheaper. So what does it matter? It depends exactly on what your customer needs. Step 5, let's think about your data transfer costs. In the cloud, they charge you to use the network. And they typically charge you to transfer across regions. So it might be cheaper. Let's say you've got a website that's based on object storage platforms. It might be cheaper to sync up what you've got in 2 regions than it would be to constantly send your data back and forth. So think about that. What else is going to help your cost? Use a content delivery network. Why? It's going to reduce the load on your servers, and it's going to reduce your inter-region data transfer charges. Because remember, data in and out of and then we can, the next thing we need to think about is regarding VPNs and direct connections. It depends. Typically, VPNs are cheaper. What is a VPN? We talked about it. It's a virtual private network over the internet, but the performance is not guaranteed. Typically speaking, a private line, direct connection, express route connection, whatever you want to call it, is typically better. Yes, sort of, so, et cetera, et cetera, et cetera. Keep that in the back of your mind. But depending upon use cases, it could be cheaper with a private line than the VPN if you use it a lot. Now, all these providers have their own tools to help you save money. But if I'm selling you something and I'm telling you I'm saving you money, keep that in the back of your mind. They have tools. Do the business case yourself. Don't trust automated tools ever. Garbage in, garbage out. You get some information. I like tools. I use tools. I look at it and say, interesting. Yeah, this is right. This is wrong, but it does give you insight, so please use them. And Azure Budget enables you to drive organizational accountability. It enables you to inform departments regarding their spending to proactively manage their costs and monitor spending process over time. It enables you to configure a cost alert based upon expenditures, forecasted expenditures for ensuring spending budgets, etc. Let's talk lastly about Azure Advisor. Azure Advisor offers personalized recommendations to optimize a user's resources through analyzing configurations and usage patterns. It helps assess how well your workloads follow best practices. It'll analyze configurations of telemetry usage while offering personalized and actionable recommendations, and it will help you optimize your Azure resources. So I covered the theoretical components of how to save money. Let's open this up for questions, et cetera, in case there are any, because now we're in the business section here. And I know a lot of you folks come from a technology background, so you may need a little help with this. If I can do about 10 minutes of business questions if anyone desires. If there's not any questions, we can keep going, which I'm totally happy to. I just always want to make sure I give you as much as you can for this super expensive free training. I want to make sure you get a great experience. Joe H., you find cloud estimating very challenging. Can I collaborate on how I do it? Joe H., I'm an architect, so I've never had to do this. What we typically do in these companies is we build the design, and we typically have something called internal sales account managers and internal sales engineers. And what do? We give them a design, and they typically create a bill of materials and price it out for us. But, here's the thing. It's not that complicated. What you have to do is as follows. Let's say when you baseline the company's systems, because I've had to do the return on investment capital modeling on this, and I do it all the time. So here's what we do. You go to the customer, and you must find what they're spending. Must. What's your wide area network bill look like? What's your network infrastructure have you invested in? What do your servers cost? What is your electric costing? What is your WAN bandwidth costing, et cetera? So you gotta find what they're paying right now. How many CCIEs do you need to make the network? How many Linux people do you have? How many this, how many everything. First, you got to find out what they're paying for what they have. Now that, you'll get the data. Next thing you need to think of is, okay, I need to take 1,000 servers that each have 64 cores and 256 gigs of RAM with this. So then what you do is you go figure out which servers they are. Google search which number of servers on Azure has 64 cores, 256 gigs of RAM, etc. And then you find the price per hour of those systems. Multiply it by 24 hours, and you get the cost per day, times 365 days per year. And guess what? Got the cost of each one of these systems for years. Then you need to evaluate how much storage are we moving over. Okay, we're moving 4 petabytes of storage to object storage. Object storage in the cloud costs X, Y, Z per gigabyte, but we have this many petabytes. How much is that? Okay, now, what's the next thing we're talking about? Next thing we're talking about is network links. How much data is going to be running over the network? How are you going to know? Well, they got a network right now. They could be running Cisco NetFlow, which will give you information on the amount of data that's traversing what. You could take that information and then determine your interdepartmental transfer charges. Then you got to look at your wide area networks to the cloud. Okay, I need these routers. I need 4 10 gig links in a link aggregation group, and I need a backup 4 10 gig links in a link aggregation group. Each 10 gig link costs me $42,000 per month because of the distance. I need 8 of them. There is this. Now, normally on the WAN, you don't pay to use, you pay, per WAN link. But in the cloud, you pay for the WAN link, then you pay a daily fee to have the link, and then you pay to use the link. So now you got to calculate those costs. Then you got to determine your usage patterns. Where's your data going? And you can calculate that from the networking thing. Then what you need to calculate is the number of employees that need to work on it, the cost of employees, etc. So that'll give you an estimated cost. Now that's just the cost. Joe, the cost is irrelevant. Wait, I'm going to say it again. The cost is meaningless. Here's why the cost is meaningless. If I could sell you right now for $1 billion, something that would give you $10 billion in return, you'd buy it. Now, you may be arranging financing, but you'd find a way to buy it. So the next thing that you need to do is quantify the problem that you're trying to solve. Okay, the customer thinks with this new website, they can get 4% increased sales. How much is 4% compared to 4% increased sales? $6 billion. Oh, wow, that's a lot of revenue. Okay, if this new design can add $6 billion of revenue, and we're 60% confident it can produce 60% of revenue, we need to calculate the expected value. So a little bit of statistical analysis tells us what that is. So now we determine, okay, here's what the expected return on the expected value of the opportunity is. And then we need to build the business case to the customer to show that by buying my $1 billion architecture, you're going to get $2.67 billion in business value. Therefore, you need to buy it. So the reason I don't really get so involved in worrying what things cost is if I can deliver more value than the cost, I can influence my customer's budget to buy whatever the heck they want or need. So when everybody says how much you want to spend on tech, I don't ask that question ever. I'm not trying to save somebody pennies. I'm trying to transform their business. So, but then again, I'm an architect versus an engineer. So I want you to think of the difference. In finance, we have finance professionals and we have accounting professionals. Finance professionals are the people that a business goes to and says, hey, wait, we've got $10 billion extra. How much money can you make us through investments? The finance house says, we believe we can get you 8% through this, this, and this. Therefore, we can generate this much money. By comparison, the accountant, which is what engineers do, they say, hey, wait, Mike, do you know you spent 22% more on your internet connection and you can buy this carrier and they're cheaper? And I say, no, thank you, because my internet connection works. And then the accountant says, Mike, you paid these bonuses to your employees. If you didn't do that, guess what? You'd have more money. And I say, yeah, but I give my bonuses, and therefore people are happy and they work harder and we do better. And they're like, but I can save you money here. So, realistically speaking, it does matter what things cost. But I'd much rather be a finance professional, an enterprise architect that can create another $1 billion budget on my customer than the person on the opposite side that's trying to save $10,000. Which is better for your customer? Take their business, make their business profitable, and make them lots of money, or save them a couple of bucks here and there so they lose less money. I'll tell you what, I make my customers money. And then, sure, there's some accountants that can cut some costs out of it later, but that's not me. People come to me for digital transformation. Chris, we can go to the next one. Almighty, have I ever had issues with companies sharing financials? No. Now, the people that I had to work to get it, but if you go to a C-level executive and you tell them, and they've contacted you because you've got a problem and they need something, you can't solve their problems without knowing their financials. When I was a management consultant, it's the same thing. As an architect, it's the same thing. So Al, this is why architects are all about emotional intelligence and executive presence and SARA skills and CXO relevancy and ROI modeling and business case development, because that's really the most critical part of our job. So you shouldn't have those issues in the future, Al, because I know where you're getting your training from. And if you do, well, I don't want to provide that information for you, then you need to make it clear. At the C level, without the information, I won't be able to provide the consulting that you desire. I can build you something in a vacuum, which may help you, or you can give me the correct information, and with the correct information, I can help you. Now, Al, I used to practice medicine. I walk in the room and somebody's got a condition. What happened preceding this? Nothing. Okay, well, you had a drug overdose. What did you take? Okay, now I'm going to draw your blood. But without the right information, you can never come up with a solution. So more CXO relevancy, more executive presence, more emotional intelligence. Now, a lot of time companies want to hide the mistakes they made. So that's all about how you ask questions. I said it this morning on a call, but it's true. I was training some medical people, precepting them many years ago. And my student walked in the room to help evaluate a patient. And she says to the patient, "You don't use drugs, do you?" And I escorted my student nurse practitioner out of the room. And I said to her, "Do you want an answer to that question?" And she said, "Yes." I said, "Then you need to ask the patient, do you smoke? Do you drink? Do you use any substances?" And you'll get an answer. But the second you tried some kind of judgmental thing, "You don't do this, do you?" The answer is always no. So it's all about how you answer questions. Because look, everybody's made mistakes. Most of what I've done in my life was clean up systems that were designed by people that didn't understand the network. Almost always. Or it was an engineer that tried to do architecture. And engineers are the smartest people in the world, but an architect's job is very different. And sometimes we had people that wanted to play architect and engineer. They wanted to design something, and oh, wait, I'm going to go build it too. Here's the thing. It's a disaster every time, because you cannot be piloting a plane and in the back taking care of the seats at the same time. The doctor can't be seeing patients in their office and starting the IVs at the hospital at the same time. So that's the key. People make mistakes, open, unjudgmental. Could you tell me what happened? I want to help you. Okay, I've seen in the industry there's been some challenges here. Could you tell me in your own words what happened? Could you share this information? Look, I see this kind of information all day. Obviously, we've got a non-disclosure agreement. I want to help you. You'll be surprised. You will never run into these problems. Great question, though. Total cost of ownership is part of what we do. Absolutely. And you know what? That's part of it, but more of it is, think about this. If I wanted the maximum performance IT pro, I wouldn't touch the cloud at all. I'd build my own cloud in my own data center. I've got no WAN latency. I don't have to deal with any of these silly pre-made services. And I'd hire the world's best software developers, the world's greatest cloud security people, the world's best networking people, and I'd have my own 100 gig connections that are bundled in link aggregation groups and have the best performance ever. But we lose the agility So it's not about total cost of ownership. I mean, that's part of it. But here's the thing. In the data center, I want to deploy something new. I got to call IBM or Dell and get stuff, and that could take months. On the cloud, I can do it in seconds. So the agility afforded of the cloud, that ability to do something better, to do something faster, and the nimbleness is great. The ability to say, I need it now, but not later on the cloud is great. So sure, you do a total cost of ownership, whether you're buying a car or renting a car. You do a total cost of ownership of buying a house versus renting a house. But it's not about how cheap it is. It's about what does the tech do for the business. This magic pen in my hand, this pen is going to help you close a $50 million deal, and you're going to get a $300,000 commission. How much did you pay for this pen? A whole lot. You're going to get a $50,000 commission. If I sold you this pen for 10 grand, would it be worth it? Of course it would. This is not engineering. This is not accounting where we're trying to save pennies. We're trying to drive transformation. If you can save a nanosecond of trade time for a bank in an algorithmic trading system, that could be $100 million a year for a nanosecond. Now that nanosecond may cost you $30 million of networking and server performance to do it. It might. But guess what? The return on investment capital is greater than that. So start thinking about how do you maximize your customer's business, not how do you minimize technology costs. Oh, by the way, that's the difference between a $500,000 architect and a $100,000 architect. The transformation of your customers, what you bring your customers. That's the difference. And yes, you'll run into some companies that are very cheap. I have no budget. And it's up to you, the architect, to create that budget by showing what your tech can do for the business. That's exactly what you need to do, and keep that in the back of your mind. So what we're going to do is we're going to talk about building high availability systems. Now I'm going to tell you at some point here, we're going to have to go to commercial for 5 minutes while I take my beautiful, beautiful cat, Cindy, who's the sweetest, cutest girl in the world, who was limping this morning, and I put her in her cat carrier so my wife can take her to the cat doctor. I'm not sure when that's going to occur, but it's going to occur in the next 20 minutes. So before we begin, if you can give me a hashtag Azure Solution Architect Expert. Marcus, I'm already seeing it. I'm loving it. Abigail Marks, yes, Cindy and Sunday. And we can't forget Noni. She's another beautiful cat. Looks just like my cat, but a little bigger. Abigail's got one of the most beautiful cats I've ever seen. Robert Welch, Azure Solution Architect Expert Training. Ashwini, Azure Solutions Architect Expert. Robert Welch, Azure Solution Architect Expert. Alexandros, Azure Solution Architect Expert. Loving that. Tracy May. Abigail Marks, Noni is beautiful. She really is. And Almighty Azure Solution Architect Expert. And Leo over there, my good friend in Sao Paulo, Brazil. Oh, that Noni, she's special. 96 degrees in Dallas. That's about where it's like where I'm at in South Florida in Palm Beach County. It's pretty hot, I'm assuming. But we don't get above 95 because when it does, we get thunder and lightning. Carlos, peace. What a nice name. Azure Solution Architect Expert. And Chindu, Azure Solution Architect Expert. Loving this. We're all here. We're engaged. And we're going to talk about, first, what we're going to talk about is the way that Azure tells you how to build a high availability system. And if we have some time left over and you want me to whiteboard it out, I'll teach you how to build a real high availability system that matters. But we first got to cover the stuff that's going to be on the test. Let's talk about what is availability. Availability relates to something being available when you need it. Okay, you know what? Let's do this, Chris. Let's roll to commercial. I hear my wife. I'm going to go put Cindy in the cat carrier, and we are going to go back to building high availability systems. And you know what? I'll even do a whiteboarding session if you guys want afterwards, assuming we have enough time. But Chris, please roll to commercial so I can take my beautiful cat, Cindy, and put her in the cat carrier so my wife can take her to the doctor. and I'll be right back.
You and I won't say no to taking care of her.
Okay, sorry about that. Putting my cat into a cat carrier is not always the easiest thing, but we are back. We are ready to do some education, and let's have some fun. So let's talk about building high availability systems. So availability refers to something being there when you need it. Thank you, Alex, for my baby girl. So, for example, let's say you wanted to go to the website, mycatcindy.com, which doesn't exist. If Abigail, who loves cats, and her cat Noni wanted to go to mycatcindy.com, and all of a sudden Cindy wasn't there, Noni the cat would be pretty sad. And then she'd go to the Sunny the cat website, her other good friend, and then Noni the cat would be very happy. Now, I want you to think about what happens in a business. You know, when I started in networking 25 years ago, it was kind of cool. We had systems, and if the network went down, nothing happened. But now let's think about today's modern society. A hospital has electronic health records. Not that they've helped, but they have electronic health records. If they go down, the nurses, the doctors, they can't see the patient's records, and someone will die. I'm not joking, people will die. The other day, one of the airlines had a glitch in their system. They couldn't fly any of their airplanes for hours. I want to know what that cost. It cost thousands of plane flights that were canceled. When AWS went down last year, businesses all over the world couldn't work because they were crazy and put themselves all in a single cloud. And when that cloud went down, they were down. Now, if they used multiple clouds, they wouldn't have had this problem. But, keep that in mind. So every business has different availability needs. If my lab for my students goes down for 3 hours because my cat unplugged something, my students are going to call me. They're going to say, Mike, I tried to go build the cloud today and I couldn't. And I'm going to go look. I'm going to see that cat Cindy powered off a server with her paw. I'm going to power it back on and nobody cares. But let's say I'm a bank and we're processing 1 million transactions an hour. And on each transaction, we make money. And I lost in that 1 hour $500 million. That wouldn't be good, would it? No. So availability means the system being there when we need it. What kind of availability do we need? It depends on the business. Think about a hospital. Can a hospital tolerate 5 minutes of downtime per year? Probably. That's 5 nines availability, which we'll get to. What if they had an hour of downtime? I don't know. Is anyone going to die in that hour? Maybe. What about 5 hours of downtime? Oh, somebody's going to die. What about a day's worth of downtime? Somebody's going to die. So it all depends on the system, how critical the business is relying on those systems, etc. So when we talk about availability, we talk about something in terms of nines. 99, 2 nines. 99.9, 3 nines. 99.99, 4 nines. 99.999, 5 nines. So when we talk about high availability, we're typically talking about either 4 nines, 99.99% available, or 5 nines, which is 99.999% available. Banks, hospitals, internet service providers need to be 99.999% available. Most businesses can be 99.99% or 4 nines available. But it's going to be based upon the business at criticality. Most would consider 4 nines available, meaning 99.99% of the time, which we'll talk about what that means in a minute. Almost everybody would consider 5 nines availability or 99.999% availability or greater to be high availability. What does this look like? Let's think about this. So now let's look at these numbers, what they really mean. First, 99% available system. God. 3.5 days of downtime per year. That's no good. But Let's talk about 99.9% available. That's the best you're going to, that's about home internet that you have that you typically get from your cable company. 8.76 days of downtime per year. You may not think about it. You're down for an hour here, 2 hours here, 2 hours there. Typical home internet. 4 nines, 52.6 minutes per year. That's not easy, let me tell you. 52.6 minutes per year of unplanned downtime. 99.9, and Eugene, no, 99.9% available means 8.76 days of downtime per year. And 99.999% of the time means 5.25 minutes. Although, Eugene, if you want to double check my math, feel free to do so. What you can do is you can take 60 minutes per day times 24 hours per day times 365 days per year. And you can do 0.1 and then multiply it times that and then multiply it times 100 and you'll figure out exactly, or well, actually, I'm not going to do math on the fly in my head, but that's typically how we calculate it. I am not Mr. Math by any stretch of the imagination, but I've been building high availability systems forever, and I've never done anything at 99 or 99.9 because nobody that ever came to me wanted that. They always needed 99.99 or 99.999. So what goes into building a high availability system? No single points of failure. What's a single cloud? A single point of failure. So if you want high availability, true high availability, it cannot be done on a single cloud. AWS, Azure, and Google all tried to say they could do it. None of them delivered a 4 nines availability system last year due to hacking, BGP errors, or power failures, impaired networks. None of them could do it. And that's why we architects have always said, never use a single service provider. So we're going to now tell you how to do it on a single service provider, which again, you should never do, but it's part of your exam. How do you do it? Well, you use availability zones. Each availability zone is a data center, so you use multiple ones. Now, the reason a single cloud is a single point of failure is if the cloud gets hacked, if the cloud is a network failure or a control plane failure, the entire cloud is lost, no matter how many availability zones that we're using. So that's why I said, you really, if you need high availability, can't do it on a single cloud, so don't even try. But for your test, use multiple availability zones. You use virtual machine scale sets. We use availability sets. We use load balancers. Load balancers are one of my favorite devices. Why do I love load balancers? Because they eliminate single points of failure. One load balancer, 3 servers. Without the load balancer, you got 1 server. If the server dies, you're done. Storage redundancy, that's good. Azure site redundancy, sure. Software redundancy, absolutely, and data redundancy. So no single points of failure. Oh, wait, a cloud's a single point of failure. So keep that in the back of your mind. But we got to teach you the certification, so we're doing that. So best practices, according to the cloud, use multiple availability zones, meaning at least 2 data centers. And if you need greater availability other than 99.99, then use multiple regions and multiple data centers per region. I'm going to tell you this right now, even if you're on the cloud, anything that requires high availability should be in multiple data centers, minimum, and potentially multiple data centers per multiple regions. This means your virtual machines, your databases, your load balancers, your DNS. Oh, wait, if your DNS is all in Azure and Azure goes down, doesn't matter how many regions you're in, your Azure DNS goes down and you go down. So you might think of a marketplace solution from F5 that you can put in every cloud, but keep that in the back of your mind. Now, when you're dealing with high availability, and I will build a high availability network with you today, I'll show you how to do it for real. We'll whiteboard it out. We'll spend about a half an hour and it'll be lots of fun. So you need redundant network connections, redundant routers connecting to the system, VPN backups, etc., or direct or private line backups. You're going to need it all. Now, we're going to map it out for you afterwards. If you're going to connect to Azure and you only use 1 router and the router dies, guess what? You lost the cloud. So you need 2 routers on both sides. The cloud providers only tell you about 1, and I'll show you where the single points of failure are. I will whiteboard it out for you soon. So, let's look at the way Azure would show you how to do it, all in a single cloud, which is a recipe for disaster. But you'd have a load balancer, and you'd have your applications spread across data centers or availability zones. This is perfect until the Azure cloud has an outage, and now you're down too. So I don't recommend this. But we have to talk about it. Now let's talk about the networking connections. So here's your network. This is your building. Here's your cloud or clouds. The only thing that gets you working to these clouds are these networking connections. If these networking connections go down, you got nothing. So typically you need primary, secondary, tertiary connections. One can be a private line, one can be a VPN. It really doesn't matter, but you're going to need that. Let's talk about security. If you're hacked, do you think your systems are working? Nope. Not at all. What is the distributed denial of service attack? Let me send so much data to you that we take down your systems. Security, security, security. Apply the principle of least privilege. I like to use the principle, I like to call that need to know. Meaning, if you don't need to know it, you don't have it. Great, right? So need to know. Principle of least privilege. Every server that you've got, somebody needs to disable unnecessary services. Somebody needs to patch these servers. Somebody needs to put anti-malware on the servers. Limit your blast radius, meaning if one thing happens here so it doesn't affect something else, by segmenting your systems. Keep unwanted traffic out of your systems with access control lists, network security groups, etc. Protect your systems with firewalls and IDS, IPS systems and DDoS protection. You got a router that connects to the cloud. Think about this. Here's my router. It's connected to the cloud. It's a phone, but let's pretend it's a router. If this thing has ports and you plug into it, you're on my cloud. So protect the physical security. I've seen buildings that have armed guards outside the data centers because you can break in the data center and plug in, you're there. So physically secure your connections to the cloud. If and when you use passwords, don't use the password. You know the most common password on the internet is actually Cisco. Because on our CCI exams, they made us use password Cisco, so everybody used it for a while. Don't make a password of your pet's name, your wife's name, your name. Make yourself passwords that are ugly, long, and full of all kinds of things. And rotate them frequently. Back up your systems. Back up, back up, back up, and back up some more. Put your backups in an alternative location. You don't want to back up your systems in your data center, right? Or your cloud. You back it up in the same data center, the cloud has a fire and your data's gone. So send it offsite. You got all these servers and up and running. Here's the best reason, the best point of virtualization. Whether it be VMware ESXi in your data center, KVM, QEMU, an Azure virtual machine, an AWS EC2 instance, an Oracle virtual machine, a cloud or a compute instance in Google, it's the same thing, all virtual machines. Take an image of your server, store those images. Guess what? If you're on the Azure cloud and you were crazy and you only had a single cloud design and the Azure cloud went down and you had all your systems backed up, you could be up on a new cloud. It won't be fast, but you could do it. Some other best practices are enable auto scaling. Because that way, if your systems get overloaded, you got more capacity. Decouple your architecture components. So if the database fails, you can store a message in a queue. Use caching. Why? It's going to offload work from your servers. Use a high availability DNS system. And here's why. DNS will run something called the health check and say, data center 1, are you there? Yeah. Data center 2, are you there? Yeah. Data center 3, are you there? Great. And it will, if data center 3 is no longer there, it won't send traffic there. Load balancers. I love to ask people what load balancers are. Here's the reason we use load balancers: to eliminate single points of failure, to improve performance and availability. With a load balancer, we can spread the load across multiple servers or devices. If a device fails, we find out through the health check, and we can use another system. So that's why we're dealing with all these things, because we want to make sure that our systems are up, running, and operational. That's why we do it, and now you understand. Let's talk about we should be making sure we've got good logging so we can figure out what's going on. We should be monitoring for system alerts. We constantly want to be monitoring for security breaches. We monitor for usage and performance. Hey, wait, CPUs are hitting 80, 95% all the time. That's the next outage. Get a little more traffic and the systems don't function. Now, I can tell this when I ask this on an interview. What's necessary for high availability? And people say 2 availability zones and 2 regions. I say anything else and they say no. And I said, thank you. You're certified, but you don't know anything. Here is the thing, change management. I want you to really think about this. These systems are like a person with their heart, lungs, neurological system, musculoskeletal system, circulatory system. They're living, breathing things. What you do in one part of the network will affect something else, which is why a single cloud is a single point of failure. If somebody's arm gets chopped off, they might bleed to death, right? Well, when it comes to networking, if I wanted to make a change on the network, for example, and I do that change and there's a batch job going on and the batch job can't work because the network's down, I got a problem, right? So change management is really key. Here's what change management is, and it's critical for high performance, high availability systems. I want to make a change. What do? I call every stakeholder, every department head. Is this change that I would like to make on Thursday night at 2:30 a.m. going to affect anything you're doing? You guess what you're going to find out? Yes, it will. And you might find out, but guess what? 3 Thursdays from now at 2 o'clock in the morning, you can make this change and it won't affect anything. That's what you got to do. So what is the first thing you got to do? Ask everyone, will my change affect you? And they all need to analyze what your changes will it affect anything. Then you need to make your change. Then all your stakeholders need to retest their systems and make sure they work. So that's how systems are made high availability. We don't just turn stuff on. It's a very disciplined approach of what we can do and when we can do it. Let's talk about storage redundancy. We're talking about making sure that we keep our data in 2 places, because if one place goes down, we want to have another place. We just need to. That's the only way we can do it. So we want to make sure that we're constantly keeping things there. Keep it in multiple places. So the good news is with Azure is they replicate your storage account in 3 different areas. So for the most part with cloud storage, when you store your data, it's pretty solid. But with Azure Storage, we've got 2 options for how our data is replicated. It can be replicated locally redundant or zone redundant. Now, when it comes to locally redundant storage, it copies your data synchronously to 3 physical locations in the main region. By comparison, zone redundant storage copies your data to 3 availability zones in the same region. For applications that require high availability, Microsoft recommends zone redundant storage in the primary region, including replication to a secondary region. Azure Site Recovery, what is it? It's a service that helps businesses keep their systems up in continuity by keeping applications and workloads running during outages. How does it work? It basically replicates your Azure virtual machines between regions, between your on-premise systems, etc., and runs when you need it. Okay, so we're going to do this. I'm going to spend about 5 minutes on giving you some guidance on passing the exam, and then we're going to have fun. We're going to do a high availability, high security architecture, and right after that. So hold on, and we'll do some architectural work. So when you take these exams, here's the thing. They're very proprietary. Here's the name of a service. Here's how it's configured. Here's how it works. So there's a lot of questions on these things. They can be lengthy. And the problem with these exams is there's going to be multiple answers, and some of them are good, but there's always going to be one best answer. So try to do it the Azure way. Our recommendations is after you finish this course, read the Azure documentation. Here's why. Azure makes the test. Azure makes the documentation. Where do you think this test is coming from? Read the Azure documentation. You want to pass the Cisco test? Read the Cisco documentation. That's what I did on my CCIE. Read the manufacturer's documentation because they are the authority on their stuff. Now, the last thing that we're going to mention on this is to make sure you get a practice test. I like to tell my students this. These exams, name of a service, how to configure that service, they're often so far unrelated from what we do, but we have to pass these exams. And these exams ask questions in a weird way, so I recommend you buy any good practice exam. I don't care which one you buy. Make sure you got about 800 to 1,000 questions and keep going through it until you can consistently get a 95 or greater. And then you know the way they answer questions. And guess what? You'll pass the exam on your first time. I don't like to see people waste their money on taking an exam, so there's that. I'm going to give you some more guidance the day before the exam. Get a good night's sleep. Eat healthy. So you sleep good. Do not drink alcohol, take any substances. It's going to affect your thinking the next day. Show up for the exam 30 minutes early. I could tell you that your physical and mental acuity will be better when you're relaxed as opposed to overstressed. So relax, get there early, 30 minutes early. If you go someplace, and if you take it in the exam, still show up 30 minutes early. And here's the reason why. I promise you, you're going to have a tech system. The last exam I took, my Mac Pro froze. And I had to power cycle, rebid, and do it 3 times. It just happened. But I was there half an hour earlier. So it was like, click, 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 reboot, reboot, reboot. Oh, it's working. Took the exam. 45 minutes later, I was done the exam. It was nothing. And also make sure you've got an ID with you so you don't have to do it. Now let's really talk about how do we design high availability systems, and let's whiteboard it out together. So actually, before we do that, let's see if anybody has any questions. Any questions before we get into high availability system design? So for up and up, I'm going to give you my perspective. There's a military perspective that says early is on time is late, and late is never acceptable. So typically speaking, I like to show up early. Chris from my team will tell you that doesn't happen anymore. But because I try to be, but sure. And keep that in the back of your mind. So let's talk about any questions for me to answer before we do some high availability system design? Okay, no questions. Let's have some fun. Let's get tacky. Every once in a while, I like to get geeky. It's kind of fun. And thank you for all the well wishes for my cat, Cindy. Let's be fair. She's not at her best today. So I want you to think about it this way. Most organizations have a data center or an on-premise. So let's call this on-premise. When it really comes down to it, everything that we think about is a single point of failure. So let's talk about how do we design a 5 nines available system for real that won't go down if and when we have a problem. So let's say we want to connect to 2 clouds. Because one cloud goes down, we've got a problem, it's going to fail. So let's say this is AWS. It could be any cloud you want, I don't care. Meaningless to me. It's, Do I go to Joe's Pizza, Sally's Pizza, New York Pizza, or Big Apple Pizza to get a pizza? I mean, I don't eat pizza, but if I did, I don't care as long as they can deliver it. So it's the same thing. So now let's talk about what this needs to look like. Now, how many data centers should we use per cloud? Well, that's me. Just deal with this. Hold on. Change this text color so you can see it. Let's get rid of the fill here. There's a reason I want to show you what goes into this. Okay. Format shape. Oh, no fill. Here we go. Change this color. So when we're dealing with a cloud provider, what we're dealing with is as follows. Each data center is approximately 99.9%. So if we want a high availability system, for 4 and 9s, we could use 2 data centers on one cloud. We could, until the cloud fails, and then we got nothing. We could also achieve 4 and 9s availability by putting 2 availability zones in 2 separate clouds. Now that's real 5 9s, because if cloud A fails, you still got cloud B. Excellent, which we could do. So let's assume in this particular case, we're going to use multiple availability zones. So call this AZ1, call this AZ2, we're doing this in multiple clouds. Now we've got 2 clouds. And we'll talk about what goes into this. Now, when you connect to a cloud provider, they love to famously say, you don't have to worry about a backup router because we are a highly available router, and it's a virtual router. And they are right. On the cloud provider side, they are a high availability router. It is a logical router which can't go down. Good, right? Well, I want you to think about this. If you have a router here that's a physical router, and you're listening to your provider, and the reason they say it's high availability is when you connect to their virtual router, it then creates a connection to both availability zones. So let's think about this for a second. Here we go. You got your router that the cloud providers say, don't worry, just connect to us. We're high availability. Can anybody tell me in the chat box what happens if this router over here dies and goes away to our connections to the AWS cloud that's fully redundant on their side? We are done. Dead in the water. We've got nothing. Nothing, 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 nothing. So what does it take to build a high availability system connecting to the cloud? Multiple routers. Now, if it really matters, let's talk about router and router architecture. Here's your typical router. It's got a CPU, it's got a power cord, and it's got a couple of ports on it, like the kind you have in your house. Now, what happens if the CPU and the router fails? You're dead. What happens if the power supply in your router fails? You're dead. What happens if the circuit breaker you have? You're dead. Fails, you're dead. What happens if the power distribution unit in your rack fails? You're dead. You got nothing. So when we're dealing with high availability systems, we need to use high availability, high performance routers. What does that look like? Well, it looks like this. So we take a router, which we're going to represent as a box. And this is why data centers don't have power failures. And when people tell you that a data center went down to a power failure, it's kind of insulting to our intelligence because they all have backup power. So here's what you're going to typically see in a high performance, high availability system. You're going to have something called a control module. This is the router's brain. What do you think happens if the control module goes away? You're done. Dead in the water again. So what do you think you should have if it matters? Multiple control modules. Now, remember in our like in your house, you get a power surge, you get a circuit breaker that fails. Well, if you only have one connection to power and your power supply fails, you're dead in the water. So what does a high availability router have? More than one power supply. Now this power supply is that connects to the cloud. If we plug in two power supplies to the same power distribution unit or the same circuit breaker, and the circuit breaker fails, but we've got two power supplies, what happens? Again, we're down, dead in the water. So we need to make sure that each power supply is connected to a second outlet off of a second circuit breaker. Now let's talk about getting this even more. Typically what happens is these routers, they have something called a line card. And that's where your 1 gig, your 10 gig, or your 100 gig ports. Let's say this is a 10 gig card. Now in this 10 gig card, we have a connection, right? It plugs in to the cloud. Let's do this. Let's pop in the connection over here to the cloud. What happens if that card fails? Whoops, we're dead in the water again. So what does a high availability router do? They have multiple cards. And each card has multiple connections. So what we're dealing with per router is as follows. We can lose a control module, a card, a link, or a power supply, and still be alive. But what if we get a software bug that takes down our router? Again, we're dead in the water. So what do we really need in high availability? We're going to need this. We're going to need 2 of these devices per cloud. And here, we're going to connect, again, line card 1, line card 2. And the reality is, we probably should set up a VPN to back up these 4 private lines on 2 separate high availability routers. Now, we're talking real high availability systems here, the kind of stuff that I do, not the kind of stuff that most people do, but this is what it's going to take. So now we want to connect to Azure. Same thing. We need 2 more of these systems. Let's try to move these things up so we've got some more space. I think you can see why. I typically have graphic artists draw my stuff for me, and all of you guys will when you get far enough in your career that you're no longer the drawing people. Plus, when you're dealing with the kind of stuff that I do, it needs to look a little better than something that I have the capability of drawing. The kind of drawing that a graphic artist can do versus the average architect isn't in the same universe. And when you're dealing with a system that could be $1 billion plus, your customers have some kind of expectations that you're going to send them something that's pretty professional. So let's bring this up. That didn't work. Let me just delete this. Bring this up a little more. Another one over here. And here, what we're talking about is as follows. We're going to multiple links coming here, typically speaking in a link aggregation group to make our routing a lot easier. We have a couple of links here. And we're good to go. Now that's how we're dealing with our high availability connections to cloud. Now in each cloud, multiple virtual machines. And now let's think about what can go wrong in this architecture. I really want you to think about it. If the entire AWS cloud goes down in two availability zones, do we care? Of course we don't. Now, if the Azure cloud goes down, but not the AWS cloud, do we care? Of course not. Not even for a second. It's all meaningless to us. Meaningless, meaningless, meaningless. Now, if we really did this right, what I typically do with my clients is I put in Nutanix or an OpenStack cloud in their data center. By leveraging their equipment, we give them all the cloud features and cloud functions in their private cloud. Now they've got their private cloud and they're connected to now 2 public clouds. What about our VPN backup? Probably should have a VPN backup, right? Yeah, of course. So now let's think about our VPN backup. in our data center because we're going to need a VPN backup. So let's think about it. Here we got our data center, right? And we've got VPNs are done over the internet, right? So we're going to need some kind of internet. So let's do this. I don't feel like. So let's say we've got the internet. Now there's lots of internet service providers, right? Now if the internet is our backup, and now we're dealing with the data center, and let's say we've got a connection to AT&T over the internet. What happens if the AT&T global network gets hacked? What happens if the AT&T global network has a BGP misconfiguration? Poof, we're done. We're down again. We're hosed. So is that a good situation to only have a single internet service provider? Of course not. So what do we need? 2 internet service providers. You will not find a network architect anywhere in the world that will ever design a network across 2 links to the same service provider, because when a service provider goes down, you go down. So what do we need? Then we need a second internet service provider. It's Verizon. Great internet service provider, just like AT&T is a great internet service provider. Okay, so now let's think of the architectural considerations of which we're using for our VPN backup. Now let's go back to our high availability router, which we could potentially use, but we won't. Let's go bring this device in, copy it, let's paste it over here, bring this down here. Let's put our beautiful router over here. I didn't need to do this. See if I can drag it down. I haven't been drawing stuff for a long time. Now this router is connected to AT&T, right? Now, if the link goes down, we're dead in the water again, right? How about if this router has a code bug and it reboots, and crashes? Guess what? We're still dead in the water. So we're going to need another router, right? Of course we are. And we're going to connect to another internet service provider. Now we've got 200 gig connections to the internet, right, everybody? Oh, good, right? Now, which internet connection do we use? I don't know. If we put a default route to Verizon, if Verizon fails, we can fail over to AT&T. But we've got 200 gig connections. Do you want to waste a 100 gig connection and not use it? Of course you don't. That'd be crazy, right? So you want to load share across both, which now means you need to take in a full internet routing table and run BGP. So for this to occur, you're going to have to run eBGP over here. And to this router. And you're also going to have to run eBGP to this router. Now at this point, router over here knows how to reach all of the routes in the internet through Verizon. And at this point, this router knows how to reach everything on the internet through AT&T, but do each router know about how to reach each other so their links go down? Of course not. So think about it this way. If your users are pointed to this router, and your users are all going to have a default gateway, right? Of course they will. That's going to point your default gateway somewhere. So if all your users are pointed to this router, now granted we'd use something like virtual router redundancy protocol, which my cloud architecture development students would know, but this is way outside of this, but it's critical information for the cloud architect. If the users are all pointed to this router, and the packet gets to this router and this internet connection is dead, we're dead. But if the users connect to this router and this internet connection dies, and now this router knows how to reach the internet routes through this router, then we're good. So what typically occurs, we're typically going to run multiple links between our routers, multiple physical links, and then we somehow have to exchange the routing information between these 2 routers. And we're going to do that with something called internal BGP. That's how we're going to do this. Now, what we're probably going to do is we're going to point half of our users to this router We're going to point half of our users to this router, and that way we're going to be load sharing. So internet service provider goes down. Don't worry, we got another one. Power supply goes down on a router. Don't worry, we got another one of them. Control module goes down on a router. Don't worry, we got another one of them. Cloud provider goes down. Don't worry, we've got another one of them. No single points of failure. Now, I just talked about the networking, but that's the thing. We're going to do this with every server, everything along the way. That's why, Chris, if we can get rid of these bots posting inappropriate content on our channel, block them somehow if it's possible, but keep going. So at this point, now you know what goes into high availability system design. We covered a complete and total Azure Solution Architect Expert Bootcamp. Got about 30, 40 minutes, and I will happily take any questions should any of you have any. Does anybody have any questions for me? You don't have to be shy. I'm soft and gentle. Is IBGP and OSPF the same thing from Almighty? Not at all. OSPF is something called an interior gateway protocol. An interior gateway protocol such as OSPF, intermediate systems to intermediate systems, etc., etc., etc. EIGRP, for example, that is designed to be used inside of an organization and is designed for rapid healing of systems environments and to promote network layer reachability inside of an organization. BGP, or Border Gateway Protocol, is an exterior gateway protocol, and it is used to connect to external organizations. Now, here's the thing. We've got an OSPF network internally. OSPF is designed to handle 10,000 routes, max or less. Now, we've got 20,000 routes, and we're connecting to the internet, and I'm taking in 800,000 routes from AT&T and 800,000 routes from Verizon. Now I've got 1.6 million routes to push across my network, and I'm running OSPF inside my network, which can only do 5,000 routes, etc., maybe 10,000 max if I got huge routers. So how do I carry those 1.6 million routes across my network? That's what interior BGP is for. So interior BGP enables an internet service provider to connect to two other internet service providers and pass the routing information. So that's what IBGP is used for, to carry externally learned BGP routes across your network. Al, great question, great question, great question. Grace, you can go to the next question. Coming to the cost estimate, does the cloud environment will only be having operational costs for usage, or do we need any sort of financial deposit? Every cloud provider is different, and you're going to have to deal with the cloud provider. Typically speaking, the cloud providers, kind of like a drug dealer, offer somebody really cheap rates for the first year, kind of like your cable company does. And then they raise your rates after the first year. Now, here's the thing. They do it to get you stuck on the cloud. But having said that, here's the good news. If it's a new business, and the business has no money, getting those introductory rates for the year could give that business access to technology that would give them a competitive advantage. So they're still there. But every cloud provider is different. And you have to check with the cloud provider each time, because they're going to run different things for different companies, organizations' credits, their size, their capability, all that's going to make a difference. Good question, though. So does this mean we should go with two cloud providers always for high availability? Well, Cloud Master, it's up to you. If your customers can go down and nobody's going to die and they're not going to lose a lot of money, then sure, use a single cloud provider. But if it matters, don't use a single cloud provider. Would it increase the cost? Marginally. So I'm on AWS or Azure. I've decided to use 2 availability zones and 2 regions, and I have 20,000 servers. Okay, in Azure. Or I could take my 10,000 servers and stick them in Azure, and 10,000 servers and stick them in AWS, and I bought the same 20,000 servers. It's just where did I put them? So all of this cloud stuff is just relocating. The cloud providers were green, we're green, we're green. How are you green? You don't have to buy any hardware. Really? Azure or AWS or Google? I don't have to buy 10,000 servers. So now I use Azure, and Azure buys 10,000 servers for me, rents them to me, and says they're green. They buy the same identical servers that I would have bought. And they use the same amount of power. It's just where you put the power. So no, it doesn't increase the cost dramatically. Here's the thing, Cloud Master. I'm all in Azure, right? Or all in AWS. And AWS wants to raise my rates. Can I do anything about it? I'm stuck. I'm in trouble. Now I'm on 2 clouds. And AWS decides to say, your rates are going up. And I say, I'm on Azure. I'll take my AWS stuff and stick it in Google and issue a press release that you raise my rates. Would you like to do that, cloud provider? And they'll say, no. Here you go. We'll offer you another service at the 10% discount. So when you deal with multiple vendors, you get bargaining power. When you deal with one and you put all your eggs in one basket, not only get a single point of failure, you've got no negotiation bargaining power at all. So I can't ever see a reason to ever use a single cloud provider. And then again, not a single cloud provider last year. None of them delivered 99.99% availability. None of them. And what about a hospital where all your stuff's on the cloud goes down and your patients are dying? What about a bank that gets 1 minute of downtime, which costs $6 million? Hey, wait, we saved $100,000 by using a single cloud. Woohoo! We lost $6 million in a minute. What are you doing? Ask you how, and this is why we architects spend 50% of our time on the business side of it. Because if my cat Cindy's website was down for an hour, who cares? We don't lose anything. Stick that in a single cloud. Now I've got a big healthcare organization that's got 50 hospitals. They're down. People are dying. So what you need to do is determine what are the availability requirements. Again, we're never talking about the tech as architects. We don't care about the tech. I don't care if the tech is a pencil. I don't care if the tech is an ice machine. I don't care what it is. All I care is whatever I bring into the business makes the business more profitable. Like I did some consulting for a hospital. They came to me to modernize their network. I'm not joking. I sat at that hospital and I watched what people do. I found out that the average nurse was spending 2 hours walking to a single ice machine on the unit. I went to the chief nursing officer and said, I have a solution for you. And she's, yeah, Mike, what's your $30 million solution? I said, it's less than $5,000. And she laughed. She said, what is it? I said, you need a second ice machine. She says, an ice machine? I said, yeah, we need an ice machine. She says, why do we need an ice machine? I said, your average nurse is spending 2 hours per day walking to the ice machine. She didn't believe me. I said, sit with me. She watched it. We put pageometers on the people. And she went, oh my God, Mike, they bought that ice machine. Now this hospital had about 1,100 nurses earning $50 per hour. And we saved 2 hours per day. Huge amount of money. So what do I care? How do I transform the business? That's all it cares for me. Almighty, you get it. I'm sure you do, Al. That's fantastic. Taipan, no questions for you. I made it pretty plain. Good. That was my whole goal. Leonardo, thank you so much. Amazing content again. Thank you so much for Go Cloud Curry's team. I am so grateful to be here. I know Chris is happy to be here. I know a lot of my team, like Leo, is here. Abigail Marks, now Cloud Hired. Thank you so much. Okay, so I'm going to close on a couple of things. If you desire to work as a cloud architect or a cloud engineer, we have a program for you. Our Cloud Architect Career Development Program will make you a cloud architect and help you get your first job. Our Cloud Engineer Career Development Program will help you get your first cloud engineer job. And our Tech Career Accelerator Program will take you if you're a working architect or engineer and help you get promoted. So we've got 3 of them. And right now, everything is 30% off. We extended our July 4th savings to help you get your first cloud job or get your cloud promotion. Next week, we're going to do a BGP and a subnetting workshop, and I'm going to get my hat with all the propellers on it. We're going to get geeky, down and deep in the technical weeds, and it's going to be fun. So please sign up for the BGP and the subnetting workshop. We are going to have a ball. Lots of fun. The week after next, guess what? We're going to have a completely free AWS Certified Solution Architect Associate Bootcamp, and that's going to be fun too. So now you know of all the free things. Register. The links are in the chat box, the description below. And Joe, I never mentioned that 90% of businesses are moving to the cloud at all. I said that 80% of customers use two or more clouds, and 97% plan on being on 2 or more clouds by the end of the year. Every business can determine where it needs to be. I see lots of small businesses moving to the cloud, but I don't use, and they typically use smaller clouds. Definitely. But, you know, realistic thing about it, it all depends. It all depends. I have a cloud, but I built our own cloud for our customers and our business. We run our own cloud. I like it. It's more agile, it's more flexible, and it's a lot cheaper for us. But I don't have critical availability needs. If I did, I'd have my cloud and I'd be connecting to 2 other clouds. No single, or even my cloud, even one cloud connected to another cloud is good because it's still 2 clouds. But it's got to be a hybrid cloud, meaning a private cloud plus a public cloud, 2 public clouds, or really, if it matters, a hybrid cloud, multi-cloud, like I just showed you, where you got a cloud in your data center and a cloud in your 2 cloud providers. And then Ashwini, thank you so much. I still have a little bit of leftover COVID, but I'm feeling good and strong, and I'm so happy to be back. Got to teach a class with my students yesterday. I was so happy. I got to see my wonderful students, and it was wonderful. So thank you so much. So hope you all had a wonderful boot camp. Join me tomorrow in the completely free How to Get Your First Cloud Architect Job webinar on Zoom. It's going to be a lot of fun. I'll tell you how to get your first cloud job, and you can even ask me questions for an hour on Zoom. It's going to be fun. So please register for the How to Get Your First Cloud Job webinar. The link is in the description below, and I look forward to helping you all get your first cloud job. I'd like to thank you for paying attention with us for all this time. Thank you for bearing with me when we had to go to a commercial, which I never do, to take care of my cat, put her in the little cat carrier so my wife can take her to the hospital, so she can get her figure out what's going on with her paw, because we want her to do this. Now, Cloud Master asked me the most dangerous question in the world, so I'm going to bring it up. Which cloud should you go to as a fresher? I'm going to ask you this. Would you take special training to drive a Mercedes, and then special training to drive a Honda, and then special training to drive a Ford? Or would you learn how to drive? So if you're a fresher, I recommend that you learn the network and the data center. And by doing that, you know every single one of the clouds. Plus, you're not exactly hireable if you don't know the network and the data center anyway. So learn the network and data center, and then you know all the clouds, and you're eminently hireable. Cloud Master, you're welcome. Joe H., you're welcome. Al, love that. Thank you. Charles, thank you so much. So join me tomorrow in the How to Get Your First Cloud Architect Job webinar. We look forward to a fun day. If you're a cloud engineer, I'll still tell you what to do because I want you all cloud hired. So Robert, 7 recruiters following up with you today. Pretty normal for my students. We're so good at building their LinkedIn profiles and their resume profiles that the recruiters come to them, and they send you directly to the hiring manager instead of wasting your time with HR getting auto-rejected because you lack experience. So Bob, and I know you've got a good background as well, so I'm so happy to hear that. And Alex, Evharisto Parapoli. Z. Seinfeld, you're awesome. Thank you so much. Take care, everyone, and I hope to see so many of you tomorrow. Please sign up for the other free boot camps. Take care, everybody.